Okay, you intend to conduct a goodness of fit test for a multinomial distribution with 5 categories, and you collect data from 70 subjects and mark the degrees of freedom for the chi-distribution for this test. So I'm using this to go ahead and just give you a general lecture on the chi-square goodness of fit test. So notice that the chi-square distribution is a right skewed distribution. Notice that as your degrees of freedom increase, your chi-square distribution actually gets more normal. So the purpose of a chi-square goodness of fit test is to understand whether or not a frequency distribution fits an expected distribution. We will not be using any population parameters such as mean and standard deviations, and instead we're going to be looking at frequency tables for normally counts for categorical data. So for the chi-square goodness of fit test to be used, the following must be true. The observed frequencies must be obtained using a random sample, and each expected frequency must be greater than or equal to 5. If the conditions above are satisfied, then the sampling distribution for the chi-squared goodness of fit test has k minus 1 degrees of freedom, where k is the number of categories. So notice that there's 5 categories here, so your answer for degrees of freedom is going to be 5 minus 1, which is 4. But anyway, your test statistic for the chi-squared goodness of fit test is going to be chi-squared. And notice that chi is more like a script x rather than a plain x here. That's often done on my computer, but it's going to be the sum of your observed minus your expected, divided by your square of that, and then divide that by your expected. Okay? We're going to use technology to do most of it for us. So when the observed frequencies closely match the expected frequencies, the difference between O and E are going to be really small, and the chi-square test statistic will be close to 0, and you'll have a really high p-value. So hence you'll fail to reject your null. However, if the observed frequencies and expected frequencies differ quite a bit, then your chi-square test will be large, or test statistic will be large, and your p-value will be small, less than the alpha level that we're testing at, and you will reject the null in favor of the alternative. So let's just look at an example where you might actually see this. The music preferences of the listeners in a radio station's broadcast region are distributed as shown below, and you randomly select 500 radio music listeners from the broadcast region and ask whether they prefer classical, country, gospel, oldies, pop, or rock. And using an alpha level equal 0.05, we're going to perform a chi-square goodness of fit test to test whether the distributions are different. So we're given these percentages here, and these are the expected ones according to the radio station. And notice that those percentages out to 100. Okay, then we actually survey 500 people, and these are the results that we get on what type of music they like and the number of counts here. And notice that these add up to 500. So based on what the at the radio station's broadcast region says, expected, and then what we think it is from our sample, let's see what the expected value for each type is. So what you have to do is you're going to multiply the decimal form of the radio station's percentages times your sample size 500, and that gives you the expected frequency. So for classical, the radio station says there should be 4%, so our expected frequency would be the 0.04 times 500, which is 20. For country, it's going to be 0.36 times 500, which is 180, so on and so forth. So that's how we get our expected frequency. Frequency is greater than 5. Each one of them had to be. Now I'm going to put in a table, so I'm copying it in the stat disk. So we put in a table for observed, and then we put in our table for expected, and I just typed this in. And since we used a random sample and each expected frequency is greater than 5, we can use the chi-square goodness of fit test to test our hypothesis test. So it can be written a couple different ways. The first way is that H sub 0 is the distribution of music preferences in the broadcast region. It is 4% classical, 36% country, 11% gospel, 2% oldies, 2% pop, and 29% rock. Your H sub A, your alternative, it could simply be the distribution of music preference differs from the claimed distribution. Or we could kind of state it really simple. The frequency counts agree with the claimed distribution, or H sub A is the frequency counts do not agree with it. So we're going to put this into StatDist. So I can already answer this question again. It's going to be answers 4. But let's go ahead and see how we put this into StatDist. Okay. Get the column back up. Get my cover back up. It would probably been better if I had this in a little table, but Control V here. Notice that it puts this in between. I need to get rid of those, so I really could just type these in, but I'm just going to go ahead and delete these out. It just takes a second. So I've got them side by side. Analysis. Goodness of fit. Do you choose equal expected frequencies or unequal expected frequencies? Well, if you go back and look here, the percentages here, you look at this, these are not equal. So according to the radio station, these were all different. If they were going to be equal expectancy, just like if you were rolling a die, what's the probability you get a 1 or 2 or 3 or 4 or 5 or 6? Those are all equal, 1, 6, which would divide out to whatever. So these are not equal. So these are unequal expected frequencies. What level was we testing this at? 0.5. The observed column, it's column 1, and expected is column 10. Make sure I'm getting. Oh, look what I did wrong. You have to make sure that you choose as counts. Evaluate. Notice that your test statistic is 22.71. That's pretty high. And look at your p-value. So you're going to run across one of these in your next few problems. And you can use this video to help you figure it out. Let me know if you have any questions. Let me get back in here to the problem and make sure that we submit. Got that one correct. There'll be a video here for this.